Okay, if you guys want to keep yapping, that's fine. I'm not going to wait for you, though. All right, let's get this going. Okay, does everyone see the overlapping triangles? Okay, first thing I'm going to ask, and this is the first thing you should check on your own. Do I have any full sides or angles given? From the givens only. Okay, ready? Is TR and TS full sides? In the triangles I'm trying to prove congruent? That's what I'm asking. No. Is TM and TN full sides in the triangles I'm trying to prove congruent? No, I'm trying to make the point that you have nothing. You have to come up with all three pair on your own right now. I gave you nothing. I did not give you any full sides or angles. So you need to come up with all three on your own. Before we do that, let's go over the 5 methods that are available to us. 13, one method to prove triangles congruent. Side, side, side. Here we go. Another method that's available to us. 14. Side, angle, side. Another method that's available to us. 7. Angle, angle, side. 17. Angle, side, angle. And there's one more method we just introduced at the beginning of this week, which was 14. HL. Okay, so those are the only 4 you have available. I'm already going to eliminate one of them. Can't be HL because I don't have what here? No right angles, no right triangles. So that's out. So I'm down to these 4. All right. So I said to you, you have given nothing. Nothing. There's nothing there. You need to provide your own sides and own angles today. Okay. I don't feel comfortable doing the numbers because I don't want to make people feel awkward. So do you see any sides or angles I can pull out here? Marlies, what do you have? RS congruent to itself. We can start there. That's a full pair of sides. And I'm going to start doing this a lot more because it's good. The diagrams look a little crazy here with all the markings we have. That is a full pair of sides in those triangles. So I mark it with an S. That tells me at least you got 1 pair down. 2 more pair to go. Kevin, got anything? I could do subtraction, yes. I could subtract TR and TM to get a full side. And I could subtract TS and TN to get a full side. I'm going to keep asking this more and more. If you're going to subtract, do I have both pairs of equal quantities written down that I'm subtracting? Yes, they're the givens. So I'm going to say TR minus TM is equal to TS minus TN. Subtraction. And nothing changes just because we're in unit 4 after subtraction. Substitution to say the actual sides are congruent. MR congruent to NS. And that gives me a second pair of sides. So now look, this is why I like to write out all the options. It's not HL. Can't be angle, side, angle. Can't be angle, angle, side. I'm only down to 2 here. So you have 2 options right now. You get me the third pair of sides congruent or the angle in between the 2 I have right now. And we did all that work yesterday for a reason, for you to start using this concept of if you see an isosceles triangle, not only are the sides congruent, but so are 2 angles somewhere. Izzy? You do not, and I'll show you why when we write the reason. So what angles do you want? Yep. N should be. I still don't know what, because you name like 20 different letters there. We'll name it. Take one triangle and name it with 3 letters. Okay, name one triangle. I'm trying to prove congruent. NSR. Name the angle you want in it. Okay, so angle NSR. There's one angle. Is congruent to, what do you want in the other triangle? There we go, MRS. And here's the reason why you do not have to tell me it's isosceles. How am I going to start this reason off from yesterday? In a triangle. So it doesn't matter isosceles or not. In a triangle, congruent. What did I just prove? Angles. In a triangle, congruent angles are across from congruent sides. There you go. That gives you a pair of angles now. Just make sure, is that pair that we just wrote down in between the 2 sides? Is it in between the 2 sides? Because if it's not, we got to keep working. It is. So that gives me enough info to say, finally, triangle RMS is congruent to triangle RNS, side angle side. This is where we're going now. This is where we're going. Anything here? Think more and more about if you have an isosceles triangle, those angles across are congruent. Okay, another one. I'm going to do 3 together, and then you're going to do a big one on your own. So go ahead, number 2 there. Set it up, highlight it, do what you got to do. Okay, you see the highlighted triangles now. Same thing when I asked in the first proof. Do I have full sides or full angles anywhere? From the givens only. Okay, this time I do. What do I have here? I have AE and ED. which are a full pair of sides. So that's going to get an S for me. Can I do the same thing for AB and CD? Are those full sides? No, they are not. They are not full sides. AC is a full side, but not AB. Okay, so there we got one down, two more to go. One down, two to go, two pair to go. Where are they coming from? Charlotte, go. Okay, looks like we're going to end up doing a little addition here, but before I can add, I only have AB and CD equal. I still need another pair of equal quantities, which comes from BC, congruent to itself. And now, yep, now we can add AB plus BC is equal to CD plus BC. Addition. Substitution like usual to say AC is congruent to BD. That gives me a full pair of sides, right? So I'm only down to two options, side, 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 and side angle side. So it's either the third pair you're going to tell me are congruent of sides, or you're going to find an angle in between those two. What else can I have congruent up here? Naomi? Angle A congruent to angle D. If some of you are wondering how, well, what type of triangle is AED? Isosceles, not only are those two sides congruent, but the angles across. So in a triangle, congruent angles are across from congruent sides. And that gives me my pair of angles, which are in between. So you guys are good to go. Side angle side. AEC and DEB. Questions? Okay, I'm going to do one more with you before you guys take on the big one on your own. It's not what I needed at this moment. What have we been using? Linear pairs or supplementary? Then you can say 1 and 2 are congruent. But you got to tell me which angles are supplementary first. Okay, now, don't feel like you have to prove the sides congruent. Is that an isosceles triangle at this point in the proof? Yeah, why? It's got two angles congruent. So we could say triangle ABC is isosceles. Don't feel the need that now you have to say the sides are also congruent. It's not needed. All right, how about a detailed reason? You've known me for a little over 10 weeks now. What would be a good detailed reason showing you know this is isosceles? Because this right here, two congruent angles wouldn't fly. Because I could be in a quadrilateral and have two congruent angles. Does that mean something's isosceles? No. Okay, so I need something a little bit more detailed than just write down two congruent angles. Go ahead, Amon. Got something? Okay, let's start there because I am in a triangle. In a triangle, what do you got for me? Two congruent angles imply an isosceles triangle. Yep. And if you did sides, I just substitute in two congruent sides instead of two congruent angles. Okay? So if you can get two sides or two angles. All right, guys, you have 11 minutes right now. This one's going to be tough. All right, this one's going to be tough. Hey, hold on. Before we start, I just want to go over not ground rules, but just make sure what you need, what you don't need in your proof. Okay, first of all, HJM is isosceles, just like I talked in the homework. You don't have to write in a separate step, JH is congruent to MH. That's already in the givens. Okay, but look at the next given. The triangle in the middle, HKL is equilateral. If you want to say any of those two sides are congruent, that's got to go in your proof. Okay, everyone good there? So you don't need to tell me the sides I marked are congruent. That's a given. But any sides in the equilateral triangle you want to prove congruent, you have to write that down, definition of equilateral triangle. Okay? You are going to prove two angles congruent, so probably how's this proof going to end? CP-CTC, but you and your group got to decide what two triangles can you prove congruent to do that. Okay? You go on your own. If you think you got it at the end, call me over. I'll look at it. If you are stuck, call me over as well. But it better be one of the 5 reasons. Okay? Don't make up a new reason on me. You got it. This one's a beast.